Hey, this screencast is about acceleration. Really turns out to be Newton's second law. So right now I'm going to ask you to watch a short video clip and number in your notes. How about letter in your notes? A to E. So in 5 lines. And then I want you to tell me, is acceleration happening? And then explain your reasoning. So as you're watching this short video clip, I want you to tell me those two things. So back to Wile E. Coyote. He's got the Acme Batman's outfit because he's certainly going to be able to catch the Roadrunner. So here it is in all his glory. You have to be amazed. All right, so freeze frame right now. So is acceleration happening right now as he's falling? Then explain why. Oh no! He falls so frequently. Ooh, jagged rocks. How about now? Is there acceleration happening now? Whoa, pulled up. Oh, seems to have it together. Right on. Roadrunner doesn't have a chance this time. Ooh, look at that. How about right now? Is there acceleration happening in C? And you know it's coming. I can't watch. Oh, how about now? And you know how it always ends. Here he goes. How about right now? Is there acceleration right now happening? Explain why. You gotta give it to the guy, don't you? I mean, seriously, he's unflappable. He just always seems to be able to pull himself up. All right, so Isaac Newton basically said that when an object accelerates, so for something to be accelerating, it changes speed or direction. So it's going to change speed or direction. Whoa, there was accelerate. Did you see that? Whoa, Ben 10 must be around here somewhere. So, and it happens when forces on an object are unbalanced. So what was that when the forces were balanced? What was that called? Do you remember that property of matter? Yeah, hopefully you said inertia. I couldn't hear you. Sorry, it doesn't work that way. But I can't hear you, no. So acceleration depends on two things. It depends on the force and the mass. So we'll go through this a lot. So it depends on two things. The force applied to an object and the mass of an object, right? So if you have a small force, what happens? What kind of acceleration is that? A little tiny foot, a little kid kicking a soccer ball. Yeah, not much acceleration. What if you have a big foot? What if you have the big foot? What does that lead to? Yeah, that leads to a lot of acceleration. So if we change the force, small or large, on the same object with the same mass, we're going to get different accelerations. Make sense? Think so? So what happens if you have a small mass with a certain amount of force? We get a pretty good acceleration. What if you have a big mass and we apply this? Doesn't that look like it would just hurt? And we apply the same amount of force to it, we're going to get a small acceleration. So if we keep the force constant and we change the mass, then we get different results. Think about that for a while. Right? Now, what if you kept, could you get the same? Could you get the same result? Can you get the same acceleration when you have objects that are obviously different masses? Could you get there? Yeah, you could. So we could get the same acceleration if you balance the forces to equal each other, the force that causes the acceleration with the mass of the object, you can still get the same acceleration. So you can still wind up with sameness there. And we'll do some maths around it to demonstrate that property. Okay, well, that's the F net, the force. That's the net force. Get it? Force. So the net force are all the forces that are acting on an object. So could be gravity, could be the normal force. This is the force that pushes opposite some other force. Could be friction. It could be an object pushing against it. So the F net means like the net. So like the total amount of forces. So here's a truck, has a certain amount of mass to it. If we add a force to it, a big enough force to move it, what happens to the acceleration? The acceleration increases. If we increase the force, we can increase the acceleration. Okay, so a direct relationship between those two. So here's that same truck. Ooh, suddenly got bigger. What happens if we use the same amount of force? The acceleration sinks. So there's a inverse relationship between mass and acceleration. So big mass, same amount of force, we get a little acceleration. And we'll do some math to look at some numbers that show that. So here it is. So you should pause right now and read through this. I'm not going to read it to you. You can read it. If you want to take some notes down here or draw some arrows like up and down, I'll clam up and you can pause and read through this. So these are the words of Newton's second law. So here's Newton's second law. Here's kind of what he wrote down. So the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction of the net force, inversely proportional to the mass of the object. That's a lot of stuff to think about. So two things to look at. Number one, if there's a force and it's causing acceleration, the force vector and the acceleration vector are going in the same direction. Number two, it's inversely proportional to the mass of the object. So we've got that inverse, that algebraic expression. So if we do some maths, some things to think about. So we measure forces in the metric system, not in pounds, but in newtons. And so if you remember, that business of a bag of ramen noodles has the same force as about 1 Newton of force, like pushing down on you. If you hold a bag of ramen in your hand, it has the same feel of like 1 Newton of force. So not a lot of force. All right. So the formula for acceleration is the F net, all the net forces divided by the mass. So if we look at this, I want you to do these in your notes. So here are our 4 situations. So the first one has 10 newtons of force. We got 2 kilograms of mass. So what's the acceleration? So if you plug that into the formula, A equals F net, F divided by M. So what would you get? So do those maths. Now, I'm not going to tell you the answers right now. We'll come back and talk about those in class. So you can pause this screencast and you can get those problems, do those 5 problems quickly. All right? So just some things to think about. You know, Newton says it simply, when an object accelerates, so in order for acceleration to happen, it changes speed or direction, right? Oh, there's accelerate again, right? So those forces are unbalanced, and holy cow. Never can get this omnitrix to work.